Hello ladies and gentlemen, today we're going to be talking about how to sketch a polynomial, basically taking a lot of the information we've been talking about and putting it all together to give us this kind of final product of what a graph, how we can kind of sketch a graph really quick, alright? So, here are the things that we're going to need to know. We need to know the end behavior of a polynomial, which is going to go back a little bit, so we're going to review how to do that. And then we need to find the roots of our polynomial and know what their multiplicity is. Okay, basically what we've been working on over the last couple of weeks. Okay, for the end behavior, just as a reminder, you have a little chart that should help you with your end behavior. If you remember, we had it kind of split into fourths where you had even and odd powers along with the positive and the negative leading coefficient, right? So the degree of the polynomial will tell you that's the even or odd, and if it's negative with the leading coefficient, that'll tell you. So for example, even positive would be up, up, even negative would be down, down, odd positive is down, up, and odd negative is up, down, okay? So that's the first thing you need to identify whenever you're going to graph a polynomial. And then what you're going to do is you're going to basically take that end behavior and you're going to put it onto your graph. So for example, we're going to be working with this function to start. I have f of x equals x cubed minus 4x squared. I can see that my degree is 3 and I have a positive leading coefficient. So I'm going to be down, up. Okay, down the left side, up on the right side. That's my behavior. That's the first thing we're going to do is we're going to plot those arrows, okay? Next thing we need to do is we need to find the roots. Sometimes that'll be easy to be factorable. Sometimes it won't be, and you'll have to use your P's and Q's and your division to find all your roots. But we know a million ways to find roots of polynomials. You're going to find them and identify what their multiplicity is. So with this one, to find my roots, I have a GCF here. I can take that out. So f of x is going to equal x squared times x minus 4. And so we're going to get that x equals 0 is a root and x equals 4 is a root. And again, I'm getting those answers by doing the zero product property. Basically, it's splitting of these two equations, x squared equals 0 and x minus 4 equals 0, and solving for x. Okay, so there's my two roots. And then I need to go ahead and say what the multiplicity of those roots are, and then use that to graph. We talked about this the other day, but just to make sure we're on the same page, when you have a root that repeats an even number of times, your graph will bounce at that point. If it repeats an odd number of times, if it has odd multiplicity, it will go through at that point, okay? It'll cross over. And so what does that mean for us in terms of looking at, also when we go to sketch this, we still have this function here. Remember, we said x equals 0 and x equals 4 were our roots. We know that x equals 0 have a multiplicity of 1. X equals 4 is a multiplicity, x equals 0 has a multiplicity of 2. X equals 4 has a multiplicity of 1. Okay, we saw 0 showed up twice. 4 only showed up once from our factors over here, right? X squared, so there's 2x's giving you the 0. So that's multiplicity of 2, okay? So I still have my end behavior for this one. We already graphed that. It looked like this. I'm now going to go ahead and graph my points. So I have 1 at 0. I have 1 at 4. And now I'm going to play a game of connect the dots. Here's how this works. I'm going to start with my left arrow here, and I'm going to connect it to my first root. So we're going to go do, 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 until I get to that first root. Then I'm going to look over here at my multiplicity and have it tell me what I'm going to do. In this case, this multiplicity is 2, which means it's even, which means I'm not going to cross the x-axis. I'm going to bounce off. Do, 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 do. Now I need to connect to this root over here, so we're going to swerve back and touch this one. And again, I'm going to do the same thing. Now this one has an odd multiplicity, so I'm going to go through and connect with my arrow up here. If you did all of this correctly, everything should work with each other. Your arrows should meet up in the end. You should be able to bounce and cross and have it so that you end up meeting up over here. What you don't want to have happen is that if you either mess up your end behavior or you mess up the multiplicity of your roots, you should not be crossing your x-axis at anywhere but a root. If you have to, let's say, for example, we thought this was even and we bounce. And oh no, I have to cross to meet up here. If you cross that x-axis somewhere that's not a root, you did something wrong. You messed up either your multiplicity or you messed up your end behavior, okay? If you would need to connect it by bouncing instead of going through and you're supposed to go through, something went wrong. Everything should work and everything should line up in the end when you're done, okay? I want you guys to go ahead and try this one. Go ahead and take out a GCF, whatever you need to do with this one. Find those roots, find their multiplicity and graph it, and then we'll meet back together and see if we all agree. All right, so here's my answer to this problem. So I went ahead and took out a GCF. I took out negative 1/2 x to leave me with this over here. I thought that would be easier, get rid of this fraction so I don't have to worry about it. Then I went ahead and factored this. I said, hey, factor by grouping, 4 times 9 is 36. What two numbers multiply to 36, add to negative 12? That's negative 6x, negative 6x. Take out GCS, factor, and I ended up with f of x equals negative 1/2 x times 2x minus 3 times 2x minus 3. That made my two roots x equals 0 and x equals 3 over 2. X equals 0 only shows up once, so there's a multiplicity of 1. X equals 3/2 showed up twice, so there's a multiplicity of 2. And so this is what my graph would look like. End behavior up, down. We have a negative odd degree. So I connect, I go down here, I go through, because multiplicity of 1. Even multiplicity, so I bounce off, and I go down, and I connect to my other end behavior. Okay? So that's how we're going to graph these polynomials. Thank you all for watching.